Welcome to this video on the topic of matrices. In this video, we'll be having a look at how we can go about performing the matrix operation that is called transposing. Now, to transpose a matrix is to flip a matrix about its principal diagonal. If we draw our attention to matrix A over here, the principal diagonal in this matrix runs from the top left element down to the bottom right element, noting that this is a square matrix. Now, to perform the transpose operation, all you need to do is flip all of the elements in this matrix about the principal diagonal. On the right hand side here we have a second matrix. This second matrix is the result of transposing matrix A. This is denoted by the superscripted T seen over here. Now, observing the arrangement of the elements in this transposed matrix A and comparing it to the original matrix A, what you can see is the location of the elements are different. So the elements are the same but just in a different location. What's happened is all of the elements on the left hand side here have been flipped about the principal diagonal. This can be highlighted using the highlighters shown here. So -4, 7 and -8 were originally down here. So the column has been flipped and now it's turned into a row. The second column, the second row. One thing to note is the location of the values along the principal diagonal, they remain unchanged. The only things that change are the values that are not on the principal diagonal. So what we see here is the transpose operation. Simply flip the values about the principal diagonal. Now, putting this to practice, we have two examples. In example 1, we have an unnamed matrix and we want to perform the transpose operation on it. This is denoted by the superscripted T in the top right hand corner here. Now, the way in which we do this is it's a square matrix, so let's just identify our principal diagonal. It's going to stretch from the top left to the bottom right because, of course, this is a square matrix. Now, filling this in, we're going to list all the values along the principal diagonal. Next step is we identify the values in the first row, 0 and 6. These are now going to become the first column. Next step, we need to identify the values in the second row, -6, 0 and 8. These are going to now become the second column. And finally, this is a 3 by 3 matrix. We're going to identify the values in the third row, and these are going to become the third column. Done. Now, to perform this operation on a calculator, I'll bring my calculator up, and I've already put the values of the matrices in this calculator. Now, to perform the transpose operation, what I'm going to do is I'm going to go Option F2 for MatFact. Then I'm going to go inside of brackets, I'll put matrix and matrix A in this case. Outside, I'm going to go back to the top and I'm going to use this F4 function trn. It stands for transpose. Hitting execute, what you're going to find is I've got the transpose version of this matrix that's seen here. If we want to verify that this is indeed true, I can key in the matrix and you can see here's the original matrix. So this is how we go about transposing it on technology. Now, observing example 2, we have a different matrix that's no longer a square matrix, rather this one's a rectangular matrix. Now, for this one, it's of order 4 rows by 2 columns. Now, to transpose this, the same method holds true. First step is we're going to identify our principal diagonal. This can be done by going from the top left corner and going all the way to the right until we run out of elements. Because this is not a square matrix, the principal diagonal, or the matrix itself, is going to be lopsided. Now, next step is we simply flip all of our elements about the principal diagonal. Now, what you're going to notice is because this is a rectangular matrix, and if we flip it about and it's lopsided, we're going to result in a matrix that's no longer of the same order. So our order is going to change from 4 by 2 to a 2 by 4. Now, next step is we need to start identifying. So we'll go from the first row, and this first row is now going to become the first column. So it will be 7 and 7 like so. Next step is second row. That's going to be -2. And this is going to stretch like so. So second, third row, 1 and 6. It's going to become our third column. This will yield 1 and 6. And then finally, fourth row becomes our fourth column. -7, 2. Closing this up, we are presented with a new matrix that is of order 2 by 4. Verifying that I've done the operation correctly, I'll bring up my calculator. I'll go mat alpha b. Here is our original matrix. Going for the transpose operation, I'm going to go F4, then in brackets I'll go mat alpha b, close it off, and lo and behold, we're presented with our newly transposed matrix. So you can see that the values have just been flipped about the principal diagonal. Now, in summary, what we set out to do in this lesson was we wanted to have a look at how we could go about transposing a matrix. This was firstly done by identifying the principal diagonal and then flipping all the values about the principal diagonal. Then secondly, we had a look at how we can perform this operation using our technology seen here.